So, guys, good evening, good afternoon, rather. Um, let's start. So, we will talk about week 7. 1 minute. So, how was your quiz one? Anybody wants to? Quiz one actually we found to be quite nice. I mean, so MLF, MLT, MLP, the pass percentage is quite high. I mean, I think by next week you will get it. So all the, all the things are being. I mean, we just signed off today afternoon. So hopefully within this weekend you will be getting the. Can you hear me first of all? If there's any problem, let me know. So anyway, so I think within this weekend you will get the uh, marks. So pass percentage of MLT is 78.2, and for MLP 83% of the people have passed. So that's a very good score, I would say. And also so there are MLTs, I think is quite good compared to better compared to MLP, because MLT, I think 40 people have obtained more than 90%, and 76 have obtained more than 80%. But that also may be a reason there. But one reason for that may also be that the number of candidates in MLT is higher compared to MLP. That is also true, right? Compared to MLP, 8 people obtained more than 90%, and 18 people got more than more than 80%. Many people have passed, and MLT only. Yeah, so mostly it's a normal distribution only, and so I think it went well for the time being. So sorry, someone is stealing something. No, I don't know. Yeah. Anyway, so please now let's prepare for the OPE. Okay, for MLP at least. MLT, I'm not sure. Can you just hold on 1 minute? Huh? Just hold on 1 minute. There's some issues coming. 1 minute. Yeah, hi guys. So let's start. I mean, without any delay, let's start. Huh? So uh, let's start with week 7. So as I was telling, I mean, now it is quite well running for MLT as well as MLP. So MLP OP is coming. Please prepare for that. Let me start with week 7 graded week 7 slides. Then we will go through week 7 collabs and let me make one doc file for you, okay, so that you also can code with me. Okay, 1 minute. uh, 1 minute, so many things are coming here. Hmm. Hmm, hmm.
Hello, sir.
Hi, yeah, tell me.
I wanted to ask for the week 5 graded assignment.
Yeah, there are some mistakes in question 7 and 8, right? That's what you want
Uh,
to ask.
yeah, that is one. Also, I think the confusion matrix question is wrong. The true positive and false
uh,
negatives. I think they was flipped.
which question was that?
I think that is
uh,
4 and 5. I think. Let me look.
4 and 5, actually we did not find any error as far as I know, but anyway,
Okay.
if it was an error, so I asked to send the re-evaluation. Okay,
Okay.
so if it is an error, you will I mean, it will be corrected. Okay, don't worry.
Okay. PCA is definitely wrong. That I checked. And I
mm,
reproduced the error also.
1 minute. Which one is wrong, you're telling?
So the 4 and 5 confusion matrix.
4 and 5, I'm not sure. I mean, 7 and 8, people were telling.
Yeah, 7 and
So
8 is definitely wrong. The PCA, I think they are applied fit transform form on the test data set.
maybe actually what happened previous time, it was wrong, and then it was somehow it was not corrected.
Yes, exactly. Yeah.
So anyway, so what I did is, see, I asked for I asked to send me the revaluation script. If so previous time revaluation script. Okay,
Okay.
so if there is some revaluation, it will already be sent to you. So I mean, sorry, it will not be sent to you. It will be taken care of. It should be taken care of. Huh? So yeah, hope so. Just wait. I asked for the reevaluation. Week 5, whatever is there. So the questions are not changed from previous time. So either I will get the reevaluation script tomorrow, or it has already gone. Anyway, it will be taken care of. Don't worry. I'm not exactly sure about 4 and 5. 4 and 5, I think only you are telling. I'll check once. You also check once.
Sir, me
Uh,
also
there,
4 and
there
Because
are
5.
there is a post on discourse. There's more posts on discourse
hmm, hmm.
about the same 4 and 5.
Same, me
Okay,
too.
4 and
Like
5.
I also got
So
them
4, 5,
similar.
7, 8. These four you are talking, right?
Yes, the PCA set of questions and yeah, 4 and 5.
4, 5, 7, 8, right? Yeah,
Yeah.
I'll just check with them. Okay, because I did not make the questions, and so I don't know why it was not
PCA, at
corrected.
least I can tell you what is wrong, what is actually the problem is.
Hmm. Yeah, okay. I mean, if it is wrong, it was changed in
Yeah.
previous year also. I'll just ask. Okay, don't worry.
Okay.
I have to ask and figure out it. Okay, week 7 collab. Yeah, so basically what happened is, it was not corrected after the previous term somehow. Yeah, I also got so busy today with the OP and everything, OP and the marks sign off. Can you guys access this document? We'll post the, the codes in the collab with it. Just check whether you can access it. So anyway, we had k nearest neighbor, right? So k nearest neighbor, we have nearest neighbor. What is nearest neighbor classifier, right? So nearest neighbor classifier, we have two different types of nearest neighbor classifier. One is a k nearest neighbor, another one is the radius neighbor classifier, right? As we have seen already. And it's a type of instance based learning and does not attempt to construct a model, just stores the instances of the training data. And classification is computed how? From a simple majority vote of the nearest neighbor. So whoever is the nearest neighbor, so two ways are there. Either it should be uniform weighted, or it should be dependent weighted, non-uniform weight, right? Before that, so there are two types of classifiers. We have k neighbor and radius neighbor. So k neighbor is learning based on the k nearest neighbors, and radius neighbor is learning based on the number of neighbors within a fixed radius. K neighbor is most commonly used technique, and I mean that is not exactly a difference, but just to remember that radius neighbor is used in cases where the data is not uniformly sampled. So in case there you face an issue on where the data is not uniformly sampled, then there is a radius neighbor classifier to be used. Choice of the value k is highly data dependent in case of k nearest neighbor. Obviously that is true. And in radius neighbor, we define a fixed set of fixed r value and so on. Someone posted a chat window. Not uniformly sampled is no. We actually we saw in week 2 na oversampling and undersampling, right? We saw SMOT, the SMOT. Wait, I'll share 1 minute. I think that is what we mean. Okay, just wait. I'll share. I'll verify again, but sampling, sampling. 1 minute. Yeah. See, how do you this one? How do you handle imbalanced data? So imbalanced data sets are those data sets where one class is very less represented than the other class. Okay. So this kind of data results in less efficient ML algorithm. So one class, as I think you are also telling that class imbalance. So one class is less represented than the other class. So what we can do undersampling or oversampling, right? So if we have a majority class, we can just compress it into a one single column, one small column, right? And if it is a small minority class is a very small amount, then we can just expand it. And how to do that? So you can use the wine quality data set. If you have this wine quality and so on, so forth, then what we can do undersampling. So undersampling refers to the sampling from the majority class. So it will be carried out using random undersampler. So I'm not pasting this code because at this point it is not required. So you can just see. Okay, yeah, okay. Thanks, Benwan. So basically that is undersampling, and oversampling is replicating some points from the minority class in order to increase the minority class cardinality. So we either replicate or generate synthetic data for the minority class, that is oversampling. So basically sampling more, right? And there are different techniques. So one is SMOT or SMOT, synthetic minority oversampling technique is there in IMB learn and so on. And there are three types of SMOT and so on. But be sure we generally do not give much question on these topics. Mostly it is, the normal things, pipeline and all. And how do you apply k-neighbor classifier? K-neighbor classifier, first we instantiate, and then we call a fit method. So classifier dot fit, and here it is import k-neighbor classifier, and k-neighbor classifier dot fit xtrain ytrain. Okay. Now what else we have? How do you specify the number of nearest neighbor? So obviously in k nearest neighbor you can put a int value. K neighbor classifier you can just write in this way. in neighbor equals to 3 and 3, so on. 1 minute. Let me, yeah. There is, yeah. K neighbor classifier equals to in neighbor equals to 3 and so on. We can do that. And what is the default value is generally 5, from 5 they start, but again this will not be asked that much. As I was telling, so weight assigning is another major thing here. So it is better to weight the neighbors in such a way such that the nearer neighbors contribute more to the fit, right? So obviously this is very, I mean, you can understand, right, that in our daily life also we stay closer to the friends or closer to the neighbors who are more alike, right? Birds of a feather kind of thing. So how to understand the nature of one person to to judge the neighbors somehow, not exactly, but yeah, you can think like that. So uniform is then when each of the person in the neighborhood weight equally, but distance means a closer point, close neighbors will have a greater influence than the neighbors which are further away, right? If I'm a middle class, I will stay near the middle class people, mostly middle class apartments, mostly not near the Ambanis and all, right? Just to not to I mean, just joking and all. Generally it is uniform. Now can we define the own weight values for k neighbor classifier? Yes, we can define the defined weights, and there are user defined weights and all which can be done. Weights parameter also accepts a user defined function which takes an array of distance as an input and returns an array of the same shape. So based on how many inputs what is the distance you want to take, based on that we can define the weight which we are assigning in the which we are assigning to the to the neighbors, okay, for calculating the neighboring for calculating the weight. Now, which algorithm is used to compute the nearest neighbors? There are different algorithms. One is ball tree, there is KD tree, brute and auto, etc. Auto will attempt to decide the most appropriate algorithm based on the values passed to the fit method, right? Based on that, we use different so I think it will be generally better if we don't know much. It is better not to disturb it much and to use the auto algorithm. That is one major aspect, and remaining things in k-neighbor classifier will take care of mostly. Then some other things sir has told. So what are the leaf size, what is the metric, and these are for ball tree and KD tree algorithms. So apart from k nearest neighbor, we saw another thing is there, right? As we saw, what k neighbor classifier is there for nearest neighbor, and another thing is the radius neighbor classifier. So up to here, what we saw is k neighbors classifier. Now what are we going to see is radius neighbor classifier, right? So in radius neighbor classifier, how do you apply? Again, the same thing. Instantiate from scalar.neighbors, import radius neighbor classifier. This will be important in your OP2, right? From scalar.neighbors, import the radius neighbor classifier and so on. 1 minute, yeah. And then you just fit with the X train and Y train. Call fit method on the radius neighbor classifier object with the training matrix and level vectors. Now, the number of neighbors is specified within a fixed radius R of each training point using radius parameter. So R is a float value here, right? So we specify it within a fixed radius. So if we fix the radius R, then the numbers within a fixed radius. So for each training point, we are fixing a radius R, right? So R equals to 1 here in this case. So how do you do that? We have radius underscore classifier equals to radius neighbors classifier, and then in bracket radius equals to 1.0. Okay. Then we have different parameters for that. But again, as we have already, what are the units of R? Venu Madhav has asked. I think it should be unitless. Okay, it is not a. I mean, it's a graphic unit distance. Mm, let me check. Let me check 1 minute. Huh? Let me check. Mm, radius neighbor classifier, right? Where we did take it from? We took it from scalar dot neighbors, right? Scalar dot neighbors radius neighbor classifier. Acha. This is radius neighbor regressor, radius neighbor classifier. Radius equals to 1.0, right? Radius is a float ranger parameter used by parameter space to use by default for radius neighbor queries. Okay, nothing else.
So range of parameter space. So it should be the same unit as the parameter space.
Yeah, it should be same unit as the parameter space. That is true. That is true. So yeah. So I think here it is. So see here it is in centimeter. So I think R equals to also R is a floating point value separated by the user. So what do you mean? Like it will be the same as the parameter space?
So if
So like this case,
let's say if you have like two variables x1 and x2, so these are in centimeters. So radius will also be in centimeters.
radius will also should be in centimeters, but
If
I
they are in
guess
kilometers, they will also be in kilometers.
yeah, it should be in kilometers. But let's say the user specifies a fixed radius r such that the point in sparser neighborhoods use fewer nearest neighbor for the classification. The data is not uniformly sampled. Radius based can be a better choice. Yeah, true. What you told is true. Okay, we think yeah that we should be that should only be working. So because when the data is not uniformly sampled, radius based neighbor classification is a better choice. User specifies the fixed radius r. So I think yeah, what you told is true, sir. I mean it should be r equals to the unit of the this thing only. You can see, I mean different algorithms are there, which I mean sir has not taught, but you can check this KD tree, ball tree. Okay, all these notes will be required because I mean not for this case, not for this course, but if you want to do something more on this, just try to read it, may be helpful. Okay, yeah. Okay, someone told something. Yeah, sure. So anyway, I mean, sir has mentioned the parameters as I was telling. So all these things are there: uniform distance, default equals to uniform, ball tree, KD tree, etc. Right? These things are there. Now let's start with the collabs. I'll try to give you the. Okay, let's do one thing. We have to solve the practice question. Uh, we will see the collab, the codes which sir has written, and we will try to see the yeah, with that we will try to finish in this today's lecture. So I'll try to put the codes here, okay, because if you also code, then it is actually a little more interesting. I mean, you also get some interest, no? Otherwise it is difficult to generate interest. You also don't able to visualize, you're not able to visualize at that point. So let's code together, otherwise it does not work. But there are so many codes, it is difficult to complete. Let's see how far we can proceed. Okay. So we have KNN on housing dataset, softmax large scale. Yeah. So is KNN in housing dataset taught in the video? Can anyone just clarify? I could not check the
Yeah, there is a video on the regression problem.
Okay.
I haven't personally done it yet.
Yeah. Okay. Okay. Let's see. Okay. Let's start. So in this case, we will start with the MNIST data set. Okay. So let me just. I'll try to put the codes also. Okay, because I want you to also code with me. Otherwise, it's just just check if it is working and all. So we can do we are doing if we are importing the things. Okay, as usual, we have import common imports, then import numpy as np, then print. I don't know. I mean, yeah, not required. Achha, import fetch ml, fetch openml is required because we will be using MNIST dataset. Then for pre-processing, obviously min max scaler is there. Can anyone tell me any the name of another this scaling technique except min
Standard
max
scale.
standard scaler? Great, great. And the name of two imputers. What are the imputing strategies? Two imputers.
Symbol imputer, KNN imputers.
CN implementer, KNN imputer. Right, right. Great. So and then we have PCA. We are importing PCA. Then we are making pipeline, dummy classifier, and so on and so forth. Okay. So again, we are doing the MNIST dataset. Now, how do we access the MNIST dataset? This way. Okay, extra dialogues. Yeah. Okay. So you can do it from here. XY equals to fetch OpenML. Then what are we doing is we are you can use it in NumPy. To NumPy you are making, and then we are doing a train test split, of course. Okay. So let's do it. It will take some time. I think the MNIST takes a little time. Then after that, we will do the binary classification. Okay. So binary classification, what we are changing the labels to binary. And
Sir,
so
I have a doubt here, sir. Sir, in that X-train, X-test, the test split that you do, I mean, there are different ways of splitting. One is this and one is a train test split. So while I was doing the practice assignment of week 6, I saw that different ways yield different answers. So in the OPE, it's a bit confusing as to what we should do actually.
That manual splitting and train test split, is it?
Yeah, yes, sir. Both give different answers.
See, if it is not told, okay, it should be told. If it is not told, always do a train test split. Okay.
Okay.
I don't know why. I mean, yeah, as you understand, I mean, there are a lot of corrections to be made in the course till still. So we all of these things we should clarify actually. So it will be fixed. But yes, what you told is true. Someone in discourse also was mentioning. I think Shreya or someone, I don't know. So yeah, do a train test split. That is my suggestion. Okay, I'll you can ask in the thing, the what you know, the revision session. Okay.
Okay. Okay, sir.
You can ask once, but as for me, I can say you always do a train test split because that is a common one. Okay. The other thing is not that common. So I mean, if it is something other than that, it will be told, and if it is train test split also, it will be told. I mean, generally it is convention to tell. Okay.
Okay. Because
Yeah,
as
so
long as we are doing graded and all, it is okay, sir. But
yeah,
finally, when it comes to OP, it becomes a little tricky.
yeah, I mean, you should not worry. I mean, this is, yeah, I mean, all these errors are came previous week. Previous time we were just running around doing things, you know. Anyway, see, you will see that the lectures also, if you have, so is Sir's Jack's lecture uploaded in the portal yet? Has anyone seen? So anyway, Sir gave a lecture here on Jax. So Jax is supposed to, you know, replace TensorFlow. Jax is better. Jax is faster. It is supposed to. It is. I mean, he was telling it was, you know, what, NumPy on steroid, something like that. He explained. So I mean, here he. So what was we were talking is here the course environment was good. Anyway, let's leave that. Let's not our part. So in binary class, so you should listen to that lecture. Okay, it is a good thing. Anyway, that is not our part, not relevant. So sorry, I deviated. My statement is always it will be mentioned. Mostly it will be mentioned. In case it is not mentioned, and if it is not mentioned, do a trend test split. But whenever we make question, right now at least, I mean currently we are making the OP questions, right? So as far as I know, I'm sure we always say that do a train test split. Yeah. So firstly, here what we do is a binary classification. This we have done before also, right? We do a binary classification with KNN, and then we eventually extend it to multi-class. So how do we do that? Let us start. I'll okay, you can check it from here. So we have we take we initialize new variable names with the -1 and the digit 0 and others. So we have y train not equals to -1 into np ones. So numpy. So what are the ones of the y train and y test? After that, what we do is we do an we check where y train is equals to 0, and based on that, if we put all those places to be 1, and if it is in test set also, if it is if the y test equals to 0, then those cases also those places also we put 1. Now there after that we do a data visualization in lower dimension. For that we are doing PCA on the data points, and then what we do, we reduce the dimensions once in 2D and then to 3D. Now this will give us some rough idea about the points, etc. So we use the variables pipe PCA 2D for pre-processing and then pipe CLF for classification. Let us see. So one interesting thing to look at is the change in the magnitude of the data points. Okay, change in the magnitude of the data points before and after applying PCA. Now we use the variables pipe PCA 2D for pre-processing for sample alone. So what is there? Pipe PCA 2D, they have made a pipeline min max containing min max scalar and PCA, and the number of components is equals to 2. So X-train PCA 2D is equals to the fit transform of X-train. So on X-train they are applying the min max scalar and PCA n components to be equals to 2. So okay. Then after that we are doing a color map. Okay, what are we doing a color map of? So what is so the one are the zeros, right? The blues are the zeros, and -1 is the I think those are the numbers which are not zeros, right? So these many red colors, all of them are non-zero numbers, and in the MNIST set that we have taken here, in the training set, these are the zero values, right? So if you plot this, so now this is important. This is the part of data visualization. This is important. See, here they are using Seaborn, right? Seaborn scatter plot. This is important. Note. Here they are using Seaborn. Seaborn dot import Seaborn as SNS, right? Dot scatter plot, and then we have done our PCA and so on and so forth. Now the same thing we want to see in 3D. Okay, 3D now, and then 3D also previously we have done in component number of components to be equals to 2 for PCA. But in this case we are doing a 3D plot, and here we are putting n components equals to 3 also. So how will that change? Previously we have seen pipe PCA 2D equals to pipe PCA 2D. Now we are putting pipe PCA 3D. That is equals to the remaining parts are same. Min max scalar in the pipeline, and then PCA, the n components is equals to 3. After that after that also X-train PCA 3D that we are representing as X-train pipe PCA 3D dot fit transform. Xtrain. So we have fit transform. We applied fit transform on it, right? So previously it was Xtrain PCA 2D equals to pipe PCA 2D dot fit transform Xtrain. Now it is Xtrain PCA 3D equals to pipe PCA 3D fit 3D dot fit transform Xtrain. Okay. So on the training set, we are applying the n equals to 3 feet. Acha. Now the case is, how do we make a interactive graph? So now we are doing a 3D plot, okay, on Python. This is, I don't think it has been taught before. I'm not sure. You can tell me if you just order. So here we are using Plotly. Okay. This is another library. It is introduced. So here it is Plotly. So import plotly.express as px, and then we there are different you know the what do you say, the keywords are there which you have to be put, and so now if you do that, what you will see is this graph. So there is a color bar, and sorry, uh, so see, it can be moved. Okay, so you can do a dynamic plotting, okay, in collab itself, and see. So these yellow colors are the, I think, the ones. So those are the zeros, and the blue color, and you can actually see, right, each of these plots you can see. So there are so many blues. So all of them are non-zero numbers. So all of the, the non-zero numbers. It's like a vast galaxy, right? We are inside it. It's very beautiful plot. Huh. And it is so you can do all your data visualization like this. So Plotly, I think, is very good for plotting the data and all. You should use whoever is using for data visualization. I know Tableau and all other things are there, and I also need to check whether which of them are good. I will suggest you two things. Okay, for data visualization, see, I have found that the apart from these 3D things and all, apart from Plotly, the Seaborn and all those things are, see, if you don't have to do violin plot, PD plot, all those things, try to learn Origin. Okay, this is not, again, this is not related to ML, but try to learn Origin. Origin is a good software for plotting, and also you have the MATLAB is not so good. Does any of you know MATLAB? MATLAB, anyway, any of you know Origin? Does any of you know Origin software? Okay, I don't know whether you know. So use Origin, okay, for if you want to plot, do a column plot, if you want to do a bar plot. Yeah, I would suggest to use Origin for data visualization. Okay, anyway, you will be learning data visualization in the degree program, but use Origin for 2D plot. This is good for 3D, and if you can use Blender also for a structure drawing, that is useful. For data plot, I'm not sure. I don't think Blender will be helpful, but this Plotly is quite nice. Okay, we can check Plotly. This is not taught again, but quite important. Anyway, let's go to KNN classifier now. So what are we doing? We are doing we are setting k to a desired value. That is how many neighbors should be allowed, and we calculate the difference between the new example and every example, right? The data point which we are trying to calculate and the other data remain the nearer data points, and this create a distance vector for us. Then we get indices of the nearest neighbors, the labels of the selected k entries, and then what we do, we if it is a classification task, then we return the majority class by computing the mode of the k labels. So basically, if it is like nearer to more zeros, like in the yellow region, so I know, right? So here, if it is here in this case, then it is at this x equals to 9.26 and y equals to minus 0.5 and z equals to 0.81. There is a good chance if we have some undetected point, then it will be a yellow color only, yellow color data point only, right? But if we have in the blue region, there is a good chance if we have an undetected data point, it will be in the blue class only. So that is what matters here, I think. Okay. Acha. Till now, anyone, any question? Okay, let me know. Now, what are we doing? We are trying to understand the working of the scalar and built-in function. We are creating a KNN classifier with k equals to 3. And we are creating a KNN classifier model. And with k equals to 3 and considering a smaller number of samples for training and testing set. The k-neighbor classifier creates a classifier instance. So obviously there are n neighbors and etc etc. So what are the number of neighbors we are taking? We are taking in number of neighbors to be 3. Acha. I'll put, so how do we create a pipeline for the classifier? Okay. Now let us train the model with 10 samples from the training set. So we are just putting 10 data points, and then we will try with those 10 samples. Okay, so index equals to negative equals to arg soft. So those are the index of positive samples and some index of the negative samples, so +1 and -1. Okay. After that, okay.
Can you explain that second line in that arg, that indexing?
Yeah, I am also trying to understand that. So
that positive one.
This arg soft, is it?
Yeah, arg sort is okay, I think. But like this indexing, the index pose.
It performs an indirect sort along the given axis using the algorithm. Wait a minute. It returns the indices that would sort an array, okay, and perform an indirect sort along the given axis using the algorithm specified by the kind keyword. It returns an array of indices of the same shape. I am actually not sure also. Can you just give me some time? I'll check it and get back to you.
Yeah, sure.
Yeah, just let me. No, I'll get back to you. I'll get back to you. Okay.
Also, that slicing is also very confusing to me.
Which one?
So in the same line, is doing some slicing.
-1 to -6 and -1. No?
Three
okay,
indices.
I'll get it. I'll get it. Don't.
Yeah, okay.
Is Amruta there? We can ask her also. 1 minute. No, she is not. Okay, just give me one day. I'll post in the discourse. Okay. Either this is that fine if I post in the discourse?
Yeah, sure. That is fine.
Yeah. What is your name?
Vishwajit.
Vishwajit. Yeah, Vishwajit will post it. Huh?
Yeah, I'll even create a thread today. I think.
Yeah. Can you just tag me once and just tell that mention that you saw in the live session? It will be easy to track. I'll just I'll ask the corresponding person who made the collab. I think Ashish only made the collab. I'll just check with servers. Huh?
Okay.
Yeah, sure. Then we are checking that the first 10 samples are mix of both classes. Okay, so we have all the positive and the negative classes. So basically we are trying to use KNN classifier only, and we are using a new pipeline. After that, we are fitting the model with the new training set, and we are visualizing. You can see that there are more false positive, and let us display both the training point and testing and the predictions. Okay, let's not go too deep in detail in that. So anyway, so we have for sanity checks, we are doing the, just let us know. Okay, I mean, if we go to code, I'm not sure whether we will be able to cover it. Let's see if any code is required. So what are we doing? We are ensuring the first 10 samples are the mix of both classes, and after that we are creating a small data set, right? So we have a stack of xtrain, and so basically, okay, we are again calculating we are making a small data set, and we are fitting the model with this new data set. So what are the models that we have? What are the pipeline steps that we have in the 2D CLF PCF 2D? We are fitting a pipeline of min max scalar and PCA n equals to 2. After that, we have for visualization, we are visualizing the PCA 2D array, the 0th element, right? And we are transforming that before putting it into X reduced. After that, what we are doing is we are just plotting the graphs. So from in this small data set, so who are -1 and who are +1, that is what in the binary classification only we are checking. So I think +1 were the zeros, right? So in that case, the blue one are the zeros, and the red color plots, the red color plots are the -1s. And again, we are doing the same confusion matrix here. So if you can see, if you want to see the confusion matrix as well, let us put it here. Okay. And so we have there are more, we can see that there are more false positives since 9 out of 10 actual labels are negative. Okay, 9 out of 10 actual labels are negative. So we have 5 labels which are predicted as 1, but not exactly -1, and we have one number which is predicted as 1 but and also classified as 1, and so on. So we can display both the training points and testing points with their prediction, etc. Okay, and so basically that prediction only they are forwarding. Now let us display the distance and connectivity using the class nearest neighbors. In fact, the k neighbors classifier calls the nearest neighbor class internally to compute all these distances. So basically they will calculate the distance to the 3 nearest neighbors and they will fit transform with it. And now they are asking different questions. So which are the first 3 closest neighbors and how close are they? So we are adding the neighbors, nearest neighbor and so on. So we are calculating for different values. So these are the distances for the particular points, and these are the other things. These are the prediction. These are the predictions. So if we have say +1, +1, -1, here in that case we have a prediction to be 1 because there are two ones. Then we have -1, +1, -1. So in that case, obviously the prediction should be -1. So these are the corresponding distances. Index, I'll just check what is index. Okay. And these are the labels. So if we have -1, +1, +1, so obviously the amount, the probability of being it a +1, is higher, right? So that's why the prediction is +1. Now again we have some confusion matrix, and we are doing the same thing for 10,000 samples from the training set. So that is, we are just putting 10,000 data points. Okay. 1 minute. So we have 10,000 for 10,000 data points. We have a 2D fit, and again we are doing a min max scalar and PCA. Same things. Then we have a classification report. So if you see, this is a good example of okay, confusion matrix display. As we know, the confusion matrix display code. So we have pipe, CLF, PCA, 2D. Okay. We have X train and Y train, and this is the pipeline steps, pipeline elements. After that, we are just putting the confusion matrix display, and we can print classification report. And here, so we have used fast 10K samples from the training set, basically for running it faster, but we can increase it further up to 60K. So basically, K nearest neighbor classifier is what we are studying here. So we have K nearest neighbor, and another one was the radius nearest neighbor, right? Radius neighbors classifier. So K nearest neighbor classifier, what we have, K neighbors classifiers and all. So what we have here, we have this nearest neighbors, and these neighbors we have fitted it into the 2D transform, and we have tried to classify it. First of all, what we did is a binary classification, right? So whether it is 0 or non-zero, right? So for that, what we have done is first of all we have calculated the 3D plot and the 2D plot, and to see the feature to reduce the features. And after that, what we have done is we have applied K nearest neighbor classifiers. And how did we use that? We have used K neighbors classifier here. We have not used a radius neighbor classifier, right? We have used only K neighbors classifier here. And what did we use for the, what did we use the neighbors number? So the neighbors number that we have put is then equals to 3, right? So this is a classifier implementing the k nearest neighbors put. Okay. And after that, we have done basically 10,000 elements they have taken from the MNIST dataset. Up to 60,000 elements you can take, but this is the this has been taken to you know, to get the program done faster, right? And so we can see what is the precision value coming, okay, for different keys. So for k equals to 1, what is the you can see that actually the precision remains almost same, right? 0.64 to 1, around point, little more than 0.65, right? A little more than 0.65. So and it stays constant. So whether we change, there is not much effect, I think, on whether k equals, k is odd, or sorry, whether the k value is changed. There is not much effect on the precision. The precision most of all remains constant, right? Now there is another part on going without BCF, where what are we doing is we are just using the KNN classifier with all the features. So we use KNN classifier with all the features in the training sample. They hope that it increases the performance of the model. Let us search for K by using cross validation, and okay, so it will take around 20 minutes. So better before that, so let us so how do we go for that? We do the K nearest neighbor classifier, and let us use the K nearest neighbor classifier with all the features in the training sample. Okay. And by applying cross validation here, CV, grid search CV, we will apply the, we will try to find the K value, right? And the what have they found here is that they have found that the base value of K is 7. After that, they go in the same way, that they are applying K neighbors classifier within neighbors equals to 7. And after that, the same thing, we have the confusion matrix, and then we are setting k equals to 1, and we are checking whether we are getting zero training error, and so on. And after that, we can do multi-class classification also. So anyway, that will take some time. I'll do one thing, as we are already 1 hour, 1 hour is over. We'll see the okay, let's see the 1 or 2 more collabs. We have soft max and keen in on housing. So maybe all of the 4 collabs, it won't be possible to solve. Okay, because I want to check I want to give you the codes for the practice assignment also, so that you can practice. Okay, maybe is it okay if I just go through the practice assignment once, then come back here?
Sure, sir.
Yeah, thank you, sir. Yeah, 1 minute. Huh? Because anyway, you don't have those codes, na? Just give me a time. So guys, what are the softwares do you use for data analysis? Is anyone here working on data analytics or machine learning? I mean, in profession or somewhere? Okay.
I'm not using it directly, but in some part of my company, they use W.
Okay, nice, sir. And what do you use it for?
Basically, to capture the analytics on the website, basically, and then see the data.
Do you use Python?
I don't think so. Like it's recorded in the database and W directly.
Okay, so once you apply Tableau to it directly, it gives you all the data, is it?
Yes.
Any
I've
modeling?
not used it myself, so I'm not fully aware of it.
Okay. but others use it. So any does it do any modeling or prediction task also, the Tableau software? I don't think so, no?
I can't comment on that.
Okay, sure. No issue. Yeah. Anyway, let's go through the practice questions. This two anyway you can write. Sorry. So yeah. Again sorry. Import numpy as NP, right? Import numpy as NP. What else was there? See, I made a mistake. So many things are going on now with all the OPs and just 1 minute. Let me check what else was there. Mission history. Oh. Change. I think it was import pandas as PD. Delete everything here. Yeah, I'll just write import pandas as PD. Okay. Okay. So we have a common data for 1 to 3. Text data is this one. A metaverse is a network of 3D virtual worlds focused on social connection in futurism and science fiction, etc. A big passage. First question is vectorize the given text data using count vectorizer object. What is the shape of the text data after vectorization? Okay, so this is a nice question because here it is asking you to convert the English language into a matrix, right? So how do we do that? You use the feature from feature extraction. We use the count vectorizer, and based on that, we are just calculating the shape, right? So this is Q1, right? Doc link. 1 minute. 1 minute. 1 minute. Vivek. 1 minute, Vivek. Vivek, is this okay? Just check whether it is okay.
Yes, thank you.
Yeah, okay, sure, Vivek. So you apply count vectorizer and it will text data is not defined. Okay, so what did I do? Oh, sure. Yeah, I'll just copy the text data here also because just code with me, okay? Because otherwise, no, you won't get much interest. I'll just code the write the thing here. So this is text data. Then what I'm doing is from sklearn.feature extraction, we are importing the feature count vectorizer, and we are using fit transform. So basically, your shape is 9,99. Now, what is the shape of text data after vectorization? What is the shape of text data after vectorization? So this question is framed in a bad way. 2 hour after should not be there. Anyway, after vectorization, after the term that appeared in less than 2 documents are ignored. What is the shape of text data after vectorization after the term that appeared in less than 2 documents? Achha. A term that is appeared in less than 2 documents that is ignored. Then what is the shape of text data? So we are checking in minimum cases, two cases. In less than 2 documents, it is ignored. Okay, so minimum for 2 cases, it should not be there. So in that case, and after that, so new CV equals to count vectorizer. Again, we are applying. So what is count vectorizer? First question should be that. What is count vectorizer? Count vectorizer converts a collection of text documents to a matrix of token counts. This produces a sparse representation of the counts using a sparse matrix. If you do not provide an a priori dictionary and you do not use an analyzer that does some kind of feature selection, okay, then the number of features will be equal to the vocabulary size. Then the number of features should be equal to the vocabulary size found by analyzing the data. Okay, so basically it will convert a collection of text documents to a matrix of matrix. Okay, and we should provide a dictionary or an analyzer, otherwise its vocabulary will be limited by whatever data it has obtained, right? Now we have file name, and these are our file names. So what is the file name and what is the file? So what is file name? File name is the sequence passed as an argument to fit. It is a list of file names that need reading to fetch the raw content. For file, the sequence items must have a read method. Okay, let's read once more. So what is file name? File name is the sequence passed as an argument to fit. Expected to be a list of file names that need reading to fetch the raw content. That's it. So from file name is the file name from where it will fetch the raw content. And if it is a file, then it should be it should have a read method. So for a file, it will read the Python file. It will read the text file. And if it is an content, then the input is expected to be a sequence of items that can be of type string or byte. Okay. So if it is a content type of input, then then the input is expected to be a sequence of items. Anyway, so so how we are doing that? We are using mean df equals to 2 to understand that the term that appeared less than 2 documents are ignored. So how do we do that? We have, let's run this code. A minute. Yeah. Now, what is the token associated with the word metaverse? Okay, so how do we calculate that? We are checking the vocabulary underscore. This is very interesting. See, this is a part of text analytics actually. So we are using c dot underscore vectorizer underscore metaverse. Sorry, underscore vectorizer dot vocabulary underscore. So by putting that, we can check any of the frequencies of the letters. I think. So what is the any of the what are the tokens associated with the word metaverse? So the token number 51 is the metaverse, right? Right. Now this is another question. So there is a thing called docs. There is a file. There is an array called docs. Docs has 3 elements, right? One is the string. This is the first question. Then the second one is this document is the second document. And third one is, and this is the third one. This is very interesting question actually. Now write a code to convert the above text into an array after tokenizing it using count vectorizer with 10 features. Okay, so you have to tokenize it using count vectorizer with 10 features, and what will be the output? Has any of you seen the this is same as our Enigma machine? Has any of you seen the what is that Benedict Cumberbatch movie? Do you know what is any Enigma machine? Does anyone know? Okay.
The code breaker, basically.
Yes, it is a code maker as well as code breaker. It was used by Hitler. Actually, made it. I mean, not Hitler made it. Hitler does not have the capacity. I mean, the scientists of Germany, they made it. So they prepared it so that nobody can understand the. So what is the text they are sending? So then our famous scientist Alan Turing. Yes, the imitation game movie. Yeah. So Alan Turing, who was later persecuted for with hormonal therapy and everything, and he died very sadly. You can see the movie, The Imitation Game. Okay, so he broke that code. Then after that, you should. So there was another machine like that which was built during Cold War also. So that I actually forgot what is the name. You should. Yeah, there is another movie called. You should see all these movies, man. I mean, there are so many interesting things. I also see. There's a movie called Snowden. It's on our famous hacker Edward Snowden. Okay. he saw that, you can see that that code breaker machine. So after Cold War, and we came to know about these techniques, and see why is there is a requirement to code a text into a to code a text, right? Because that, so that nobody knows, nobody can understand. If you just send a matrix like that, nobody will understand that this means this thing. Only me and you know. If I send you this matrix, nobody will understand, right? What is the purpose, or what is the meaning of that matrix? But if I now I send you this code somewhere, you also know, and you will know that this is the code breaker. So you know, you can replicate it. You can you can encode and decode it, right? So those are the basic applications where it started from. You should see these movies, man. I mean, there is a Edward Snowden, and then there is this Snowden, there is Imitation Game, and there is another movie called I don't know whether you've seen Transcendence. Okay, it's by Johnny Depp. So you should see that. That is based on chatbot, a sentient chatbot. If you have seen, if you know about uh, if you know about the, currently what is happening, Google recently fired one employee. You check in the internet, Google recently fired one employee because they are making one chatbot. It's called Lambda. Okay, Lambda. So Lambda became so one employee sent a mail that Lambda became sentient. Sentient means self-aware. Okay, so Lambda can talk with you in about politics, and it can ask you existential questions and so on. So Lambda became very sentient, and so one employee wrote to the Google, but Google actually fired that person because it believes that we do a lot of anthropomorphizing and so something. I mean, like we try to imagine it as a person, but it is not a person. Okay, but the chatbot is so beautiful that it can appear as a 7 or 8 years old. I mean, that's how it appeared to the person who was fired, as a 7 or 8 years old. Okay, who is talking. So he came forward, and you can read. I was reading in the Washington Post. You can check it. Please check it. That full conversation is there, and so those are the important aspects in this case, right? There is very numerous interesting things. Anyway, number five question. Uh, so if you just if you write this code, we are using count vectorizer, and we are fit transform, then we will get a code like this. Okay. We have to see why is exactly doing the code. I am not going into those details. I'll finish it, and if I get some time, I'll come and we'll check in the count vectorizer, and the code library we will check, and learn more about the count vectorizer. Then we have a function called key closest in Python. In question number 5, we have a function defined called key closest in Python with the signature def k closest. X is the set of vectors as np.handy array. P is the test vector as np array. K is an integer which returns the closest vectors in X which are closest to the vector P, etc. Which returns the closest vectors in X. Yeah, so I mean, we have to we'll change the question statements a little later before the next term. So which returns closest vectors in X, and which closest vectors, and they are closest to the vector P. Use the appropriate scalar methods. Consider X equals to np dot as array. This is the case, and P equals to this. What is the output of the function? Of course, first of all, we import numpy as np. Then random seed is used because to, but again, this will also be put in the question. Okay, I mean, do not think that it will be the random. What is the random state that will be put in your question paper? Okay, before you solve the question. So these things we need to will clarify. I mean, in the if it will not happen like this in the exam, we will clarify these things. Okay, now we are defining a function k closest. Okay, X is np dot in X is an array, and numpy array. P is also numpy array. K is an integer, and it is equals to 1. After that, we are applying X closest. I'll just put the code once. you also write. Okay. And then we have the x closest. We are applying fit, and then we are applying the k neighbors. Finding the k neighbors of a point is the part of the is the target of the k neighbors. Okay, and it returns indices of and distances to the neighbors of each point. So the neighbors indices and the distance to the neighbors it returns. So if we run it, okay, and so for each case, I think what it is applying is so what did it ask? Which returns closest values closest to the vector t. Consider this is the case for these values. What is the output? Okay. Sorry, someone texted something. Yeah, Himanshu, just wait. I was just pasting it somewhere. 1 minute, Himanshu. Okay. Yeah. So after that, we are putting x equals to np dot x array. Yeah, sure, Himanshu. And for all these three cases, we are checking for all the options that we check which one is the what is the output for these cases. If we check, then what is the output of the function? So which one is the closest one, right? So if we check for these options, okay, then what are we getting? We are getting the 20, 47, 88. That is the array which we are getting, right? So 20, 47, 48, 88 is the option 4. So in this case, option 4 is correct, right? So we imported numpy. Then what did we do? We had the nearest neighbors fitted, and then x closest is the nearest neighbor fitting. Okay, and after that we are checking for all these 4 options, and after for all these 4 options we check which one is the closest for k equals to 1, and then we get that the option 4, that is 20, 47, 88, that is the closest one. Okay, then oh sorry, I didn't see my camera was off. In question 6 we have a function called distance in Python with the signature def distance equals to a vectors as np dot array. X is a list of vectors as np dot n dimensional array. P is a value for Minkowski distance. Default is 2 for Euclidean. Just wait 1 minute. Let me have water. I'll come 1 minute. And which returns a list of calculated Minkowski distance between the point x0 and all points in x. Recall that the P Minkowski distance between x equals to x equals to x1, x2, x3 up to xn, transpose of that, and y equals to y1, y2, y3, y up to yn, transpose of that is defined as the Minkowski distance is defined as, okay, x1 p is the power, I think, p value, okay, whatever, mod of x1 minus y1. So for Euclidean distance it is equals whole to the power square plus x square minus y2 whole square in mod plus up to xn minus yn whole square whole to the power 1 by 2, that is root. So basically the one which we saw in maths 1 straight line, right? The same thing, right? That is also a Minkowski distance. Now do not use any predefined function to calculate the same. This is the function which we are supposed to take. Consider x naught equals to np dot array 1. So what is the numpy array? 1 0 0 0. And what is the numpy array? That is the these are 3 arrows. 3 arrays are there. 1 then 0 0 0 then 1 1 1 2 0 0. Then what is the output of the function distance? x0 x comma x comma p. Okay. So we have to calculate the function output of the function distance, right? So we are defining a function def distance. Okay. If x naught is scalar and x is an array of the scalars, then we pass. Else we assert that the x naught dot shape of the zeroth element. Achha, if x shape, achha, let me first give you the code. That is also important. Okay. So def we are defining a function called distance. Distance we are having an numpy array called x0, and x is an np dot nd array, and p is an integer equals to 2. Let me see what else was shown here. So nd array is an array object representing a multi-dimensional homogeneous array of fixed size items. Okay, fine. An array object representing a multi-dimensional homogeneous array of fixed size items. Okay, fine. So then we have x dot shape of the numpy nd array objects, and we have as np dot as array, that is also a built-in function. If x naught is a scalar and x is an array of scalars, then pass. If it is equals to x shape 1, then the input vectors must have identical dimension. Okay, fine. Then and okay, I'll also check. Then what we do is we do a distance, and we calculate the distance equals to lambda y. So basically this is the function which we are defining for the Minkowski distance. Okay, so we have np dot sum. This is the function line up to where this is the Minkowski formula which they are calculating, and after that they will define the distance. So here what we have, this is called distance. So now for these points they are calculating the distance. Okay, so we have this is the function definition, and this is the this is the function applying. We are just applying the function here. Okay, let me see. So 0 0 0 2 2. Okay, so these are the distances that we have calculated. Okay, now okay, so this is the option 3. Now okay, using acha. So I think this one was up to here was with the function definition. If we do not use any inbuilt function. Okay, now what happened? So this is the complete inbuilt function. So this is our method 1, right? Uh, as far as I am understanding, so as far as we think, so this is our method 1. And another thing which we can use, method 2, right? What is method 2 here? We can just use the scipy dot special library to import the Minkowski distance, and if we just apply from here x0, x and 2, okay, directly we can print the distance. So that will also give us the same result, which is 0 to 2. Okay, so both ways are possible. We can do one what do you say, we can do a user defined matrix, user defined distance, user defined formula, as well as the Minkowski distance original formula. So both are possible. Now I think up to 11 is the graded question. After 11 is the graded question. So 1 minute. Which one, Vedanta? The sci-fi one? It is there, no? 1 minute. 1 minute. I'm so sorry. Now is this okay? Yes. Okay, great. Now we have a common data for question 7 to question 11, right? So you have the digit data set, and we use softmax regression. Softmax again, sir has taught in the course. So we'll also see after the this is if we finish within time, we'll see the softmax collab. Else, if anyone needs any code from the collab, na, just let me know. Just tag me, or just let me know in the discourse or somewhere, or you can mail to me also if you have my email ID. Just better in discourse. Just let me know which part of the code you need. I'll copy it. Okay. Acha. Then we have we load the digit data set on the collabs and we use softmax regression. What are the steps? We load the data set, we split it using the train test split. What are the test sizes that we are keeping? We are keeping test size. See, this is the one which we are talking about. Okay, it will always be told like that generally. Huh? We will use train test split and keeping test size equals to this and random state is this. This will be kept in the question paper also. It will be mentioned, should be mentioned like this. Okay, mostly mentioned like this. Achha, use standard scaler as a scaling function to scale the training and testing data. Okay. And in step 3, what do? We use logistic regression as an estimator and set parameter. Now, what is the shape of the features data that you get in the digits data set? Then obviously, we calculate the shape of the feature matrix, right? Okay. Achha, can anyone tell me when is the OP? Anyone? So we will have the OP. In this OP also the calculating the shapes and all are important. Huh? So you will be asked to load the data. Again, there will be one 5 version of one data set. Okay, so basically 5 data sets, 5 CSV files, which will be given to you in the portal. And from there you have to download one day. You will be randomly allotted one data set. So either it is first version, second version, third version, fourth version, 10th version, so on. Okay, one of the student will get one data set. Now the first question will obviously be which data set you have obtained. It will be unmarked. I mean, there will not graded question, but it will be asked that which data set have you obtained. After that, what you have to do, you have to load the data set. How do you load? pd.read.csv, right? After that, what you do? You apply pre-processing. You apply imputer. You apply standard scaler. Can you make a pipeline? That you will be asked, right? To make a pipeline from the scratch. Then you will be asked to to check some of the shapes. So what is the code to check shape? So the feature matrix, if you want to make, so x dot shape. If it is a training set, then x train dot shape. Okay, and so on. So after that, what you do is you go to, say you have PCA, you have RFE, sequential feature selection. So so how do you select like top 3 features? How do you select top 30 percentile features, right? Select k features, select percentile, and so on. So those things will be there. After that, you go to linear regression. After that you go to regression. So SGD regressor can be there, and all other things. Okay, so up to week 4, this way, one data set only you will proceed, and you will carry on. Okay, so there will be a flow in the question. Suppose you will be asked to load one part of the data set, then you will be asked to do a train test split again. You will be asked to do a train test split and or manual split, whatever is required. And after that you will go through the you will be getting the training set of the feature matrix, and then you have to apply different techniques, pre-processing techniques on it. So those questions will be like 3 marks question, 4 marks question, 1 marks question, 5 marks question, and so on so forth. So mostly that is the OP going to come. Yeah, will not waste more time. Anyway, I'm actually quite happy with the quiz result. I mean, I am very happy that at least 80% above people have passed. But anyway, this is quick. Sorry.
When will we get to the score of the quiz?
Just actually just before coming here, I finished we finished sign off. So maybe in weekend or next week hardly. I mean, see, all the courses come together, right? Then yeah, just wait for other courses also to happen.
Okay.
Yeah, but MLT I have seen 78% is passed, and MLP 80% of the people, over 80 actually, 83, 84 is the pass percentage. And yeah, I am actually happy. I think, and many people have obtained more than 90% in MLT as well as MLP. I think it would be more if actually MLP, I think the student number is less compared to MLT now. So at least 10 people, I think five to 10 people have obtained more than 90%. Anyway, I mean, it's a good score. Sorry, someone is stealing something. What is passing marks? I think 40 or something. No, I forgot actually.
That is 40%. Like
Yeah. I mean, pass. I mean, see, sir. I mean, we understand. I mean, you are there, and all of you are good students. I mean, why passing is not an issue now? Yeah, passing. I mean, mostly if you study, if you, I mean, you have all studied, right? You will pass. That was not my doubt mostly. There is so many, but I wanted to see who is getting highest and all. Yeah, let's see. Okay, once everything settles down, we'll just take note who is getting highest. Yeah, and yeah, so a student, one thing which is still we are missing is that there are 500 students at least. So taking a personalized care is important still. So like many students are very well known to us. Jayadev is very well known to us. Anandaya is well known. Then Mr. Bhupesh is here. He is also very well known. Everyone is mostly whoever comes to live sessions, we know it, right? So we try to look. Then Monoshrita was here someday, so she's also well known to us. Oh, hi. I think Gurneet is here. Gurneet, you were in Paradox, right?
Yes, sir.
Yeah, hi, Gurneet. I didn't know
Hi,
you were in MLP. How's
Hi.
everything going? Hey,
So it was
Gurneet.
going fine, trying to pick up the pace.
Hey, Gurneet, is Jack's workshop recording uploaded? Do you know? Some students were asking me.
Sir, the recordings, right? Actually, they are from the POD site. So I'll
Okay,
just ask for them how it
okay,
is.
well, no need. They will upload. Then they will again become busy. And anyway, there are so many things going on here. Okay, okay, yeah. Thank you, Gurneet. Yeah.
Yes.
So those are the things, right? Pass percentage is not. I mean, you will pass. I mean, everyone will. Mostly people will pass. That is okay. I mean, all of you study hard. Yeah, who is getting highest and who is getting more than 70-80%? That's the unique new thing to say. Anyway, leave it. So we have how many levels are there? We have some return counts, and this is how we calculate. These are the, so we are using the digits data set, right? So load the data set and okay, digits data set, and based on that we are calculating. So obviously we have, these are the unique data sets up to from 0 to 9, right? I'll put the code here. And okay, what happened? Why is not defined? Okay, sorry, I missed it here. Okay, now digits data sets is not defined. Anyway, I mean, I'll check something. I have to import the data sets. So how many labels 7 are there? So 7, how many times label 7 is there? Okay, so 7, you can see 179 times 7 is there. Then 178 times 0 is here. 182 times 1 is here, and 177 times 2 is here. 2 is here, and so on. Okay, so that also you can calculate from the np column. We are making a stack. Someone is saying something. Naive base. Naive base. Naive base, Himanshu. How should we see naive base? Which book you are using? Are you using any books for understanding naive base? Okay, wait, I'll check. See, one first thing which you should do is you should let me check whether it is whether there is any article on Wikipedia. Okay, for the first thing, I mean, anyway, search thing is there. You check what is the Python's doc manual telling. Okay, before that, the first step should be Wikipedia naive base. Huh? So if it is naive based classifier, you can check here. Okay, so read this complete article. Okay, and that will be a good place to start. Then whatever sir has taught, okay, whatever sir has taught, check all those keywords. Huh? In I'm telling it from the MLP perspective at least. Huh? So check all those keywords and understand the, in Wikipedia you try to understand the full article if possible. Huh? That will give you a at least a MS PhD level interview. I mean a quite a solid. I mean first point of it will give you first point of experience. Okay, that knowledge it will give you. It should be good enough. Then what you do is you follow the you take the keywords which sir has used. Okay, maybe take the from the slide itself. Okay, then you try to understand all the words, all the keywords, whatever keywords sir has utilized. Huh? So in naive base when he is applying, what are the keywords that he is utilizing? Huh? And check if it is scalan, then scalan dot scalan this thing and then the keyword, and you do a search in Google. Okay, and whatever in the manual is coming, what in the scalan manual or whatever the legitimate manual is there, read that only. There you try to find the at least you try to understand the first few lines. Okay, like here as I was telling, uh, here first thing which you should understand is what is nearest radius neighbor classifier. Suppose sir has used here, so you should understand, you should remember this part first. This is a one line answer, classifier implementing a vote among neighbors. Although question will not come from here, that much you are sure, because question will come from sir slide only. But this helps where now, because many of the examples that we gave in quiz 1, many of the this is the code, what is the output were taken from this part only. Suppose this one, if I give you what I can do, I can just give in quiz 2. I'll just give that this is the example, this is the this simple thing. Let me show you. We can hide the ones and we can just say this is the thing, and the output of this line nay.fit was in a comment I can give radius neighbor classifier. Then what is the output of I'll give you an easier example there, because here it is you have to calculate here. But what we can do is we can give a question like that. So this example, then see in here also they I know, I mean Wikipedia is editable by everyone, so you should not trust much, but here in these articles it is not that much changed. Okay, you can read this, and if possible go to the Wikipedia reference. Okay, many of this so this see the further reading. Then there see I think I shared one article from here also, the Andrew Ng thing. Then see there are so many nice books. So this book chapter you can read. Let's go. So all the see these all this there are so many important documents which you can take from here. Okay, read this. So many of the US and European faculties, what they do is they write, and many of the PhD theses are in this format. Okay, this come in the HTML format, which are free books. So this will help you a lot. This is Stanford. See, this is Stanford, from this book is from Stanford. What is the content? Let's see. What is the book on? NLP, I think it's in NLP. So these are these books you can read. This is in NLP, I think. So these books you try to read if something is required. This is not required. This is again going to the research level, not that much important. But this first of all you try. This is a good starting strategy, I would say. Start from here, then go to try to understand. See at least this first page, this first part. Okay, this in this part from here to here you understand. Then introduction, as far as you can go. Okay, it will be helpful. This small formula Okay, and that will help you. Then if possible, the derivation also, some derivations can be there. These diagrams, if you understand, okay, that will give you more than enough solid knowledge. Then if everything is done, then you go to the for MLP, you go to this part, the library, the sklearn library, or somewhere where you go and you can just check. Okay, you just practice these things. Then if more is required, you go to user guide, but again, we do not give questions from here. This is for your own further reading purpose. Okay, that will help you. Acha. Yeah, let us go through the questions. So we have results equals to np dot column stack, and here we can see that seventh is the number 7 is 179 times repeated, right? So this we I think have pasted. 1 minute. Yes. Yeah, so anyway, sorry, this was pasted anyway. Now, what is the accuracy of the trained model on the test data? Again, and write the F1 score. So basically, classification report they will ask for. Okay. So we have the dimension. Okay. Yeah, so this is a classification report. And after that, the graded question starts. So graded question, I'm not going. So for this part, question, what is the accuracy and what is the F1 score? So first of all, we can get the train and test data shape. Okay. So how do you get that? You do a train test split, and you have, so from sklearn we import the train test split. Then we have we import logistic regression. We are doing a train test split, and with training size, what is the training set size? 80%, and so on. Now, then we import standard scalar, and we import pipeline. And what is our standard scalar? What is the pipeline? We have the logistic regression, we have standard scalar, and see, these are the things which we saw beforehand, right? We have solver equals to sag and saga. These were the things which we had. Okay, and then we fit on the training set, right? So let us put the code here. Okay, then we print what is the predicted value for a particular place. So you have actual value from the test data to be this much and corresponding image. Okay. Oh my god. So if we print a 1, it will look like this mostly. Okay. Okay, nice. So we print the actual value from the test data is this, is 1. So we have predicted 1 and the actual value is also 1. The corresponding image will look like this. Okay, like 1. Looks like 4 to me. Anyway. Right. And at last we had the questions that we had in the what is the F1 score, what is the accuracy, and so on. For that we obviously need the classification report, and that we can get from here. This you know already, right? From sklearn.metrics we have a classification report, and we can calculate our F1 score as well as precision, recall, everything. And apart from that also you can calculate. So here also you could calculate, and in the test set you can do all those things. Let me, this is one, and then accuracy score is 0.96944, which is coming again, and then recall score, precision, recall, and everything you understand, right? I mean, this all we have studied previously. Here all of this can be coming from the will be coming from the classification report only. So precision, recall, accuracy, as well as F1 score, right? So that is basically the quiz, sorry, the this thing, the practice questions in week 7. So I don't waste too much time now on the practice questions. Huh? This full week you can utilize for solving the graded answers. Do the practice assignments today. I mean, just run the code. You have the codes and everything, right? So finish the practice assignment today. Activity question. Let me see. There are not much activity questions. I will try to form today. Okay, so we had large scale machine learning. Which of the following methods can be used to handle the large data files in machine learning? Work with a small, which of the following methods can be used to handle large data point? So work with a smaller sample, stream data, or use incremental loading. Incremental loading was used, and now we have Apache Spark and all, right? Hadoop, and so you should learn all these things. Okay, so one other thing I would like to say, sorry, I'm again deviating, but just I wanted to say there is a thing called this one is, I think, maybe important if you are like into self-learning and all. This is a website. I don't know whether placement cell has already suggested it. There's a website called cognitiveclass.ai. Okay, you should see it. This is a very nice. I mean, I also learn many things from here. So just I'm putting it. Okay, in case you're interested, huh? So we have all these things are coming up now, and you will also sit for placement. So they are asking for many things, right? So learn many. You can learn. This was made by IBM as a this thing, social responsibility, right? So you can learn. So these are all free courses. So I mean, again, not like you have to do or you should do something like that, but this is just a source which I found useful. So you can do many things. So one is the Kubernetes, Docker, all these things you have to do right now. And then you can earn different badges also. You have Kubernetes, then data ops. ML ops is very important these days. TensorFlow, I will try to arrange a session maybe on TensorFlow, but right now we have not studied, right, TensorFlow yet. TensorFlow, and in deep learning also, in our portal, as you understand, right, in the portal it is difficult to work on TensorFlow because it will not be able to handle all that processing. So anyway, try to see those links and try to see the courses if it is helpful. Then option 2, question number 2, we have statement 1, sklearn processes large data in batches, updates the model parameters for each batch. And statement 2 is incremental learning is a dynamic technique which is applied when the training data. So we have to say true and false. Basically, the sklearn processes large data in batches, upload the model parameters, updates the model parameter for each batch. Okay, that is a true statement. And what is incremental learning? That is also talked about in the large scale model, right? So incremental learning is a dynamic technique which is applied when the training data becomes available gradually, over time, or its size is out of the system. So this is not exactly the but still this is a definition. You can see a short definition of the incremental learning, right? So incremental learning is a dynamic technique which is applied when the training data becomes available gradually over time or the size is out of the system memory. So both the statements are correct here. So that is why option E is correct. Which of the following is not an attribute? This you can check from the by writing question mark partial fit or something like that. Then it will give you learning rate. So anyone any question in the activity question till now? Have you found any errors or something? Just let us know if you find any errors. We'll try to catch it. And then we have following statements and choose appropriate actions. The stochastic gradient descent. So basically true false statements only is coming, right? In both cases, this case also the statement 1 and 2 both are correct. count vectorizer converts a collection of text documents to a matrix of token count. Yes, that is also true. That is what we just now saw. Mark the correct statement about count vectorizer and hashing vectorizer. Okay. Hashing vectorizer we have to see, but count vectorizer does not store the resulting vocabulary. Okay. But hashing vectorizer does not store the resulting vocabulary, but count vectorizer stores it. That is the option B, and option D is hashing vectorizer a good choice if you are falling short of memory and resources. Because count hashing vectorizer does not store the resulting vocabulary, right? So that is why it will be a good choice if you are falling short of the memory. So option B and D are correct. Then we have question number 9. We do not force the matrix size explicitly with count vectorizer. Matrix size is based on how many unique tokens are found. Acha, matrix size is based on how many unique tokens are found in the vocabulary. Okay, whether this statement is true or false. I mean, again, the question should be formed more properly. So the matrix, yes. So this statement is true or false. So yes, this statement is true that we do not force a matrix explicitly. Okay, the matrix size will be given. Will be based on how many unique tokens are there. As we discussed, right? I mean, if you do not have a dictionary with it, then it will give the same, give the complete vocabulary. Okay. So just let us know if anything else is there, if anything is required in the full activity question and practice questions. We'll try to figure it out. I'll check about the week 5 errors 4, 5, and 6, 7, and the other question which the code snippet which he was telling about. I forgot the name he was talking about. So he told he will post in the discourse and will tag me. So that also I'll check tomorrow. Okay. Okay. Anyway, yeah, let's stop here and we'll prepare for the OP. Okay. And we'll meet again on Saturday. After that, I think someone else will be taking the sessions from next week. Yeah. Let's see how everything goes. Okay. We'll stop sharing then. Oh, hi, Jaydev. Jaydev was here. I'm so sorry. Okay. Is anyone online? Okay, we'll end then. Let me know if anything else is required. Yeah, thank you, Benumanda.